Hello everyone, Happy New Year and welcome to yet another learning video in our series about logic gates. Logic gates are fundamental building blocks in digital electronics. They perform basic logic functions that are fundamental to digital circuits, and understanding how they work is crucial in building more complex circuits. In today's video, we are going to look at the NOT gate. Also known as an inverter, the NOT gate does exactly what its name suggests. It flips the input. Let's demonstrate how the NOT gate works. So this is its symbol. This is how it works. So if the input is 1, that is when the switch is on, the output is 0 because our LED is off. If the input is 0, that is when the switch is off, our output will be 1, that is our LED will be on. Now let's build our NOT gate circuit. So to build a NOT gate circuit, we will need a breadboard, one LED, one NPN transistor, two 320 ohm resistors, a switch, 4 jumper wires, 2 batteries with a battery holder. We are going to follow this circuit that is drawn on our model. Now let's fix our components on the breadboard. First we are going to fix the NPN transistor. So as we saw in our previous video, our NPN transistor, it has the emitter. So this terminal is the emitter. The middle one is the base, and this one is the collector. So from our circuit, so this one is the NPN transistor. So this terminal is the emitter, this is the collector, and this is the base. The LED is connected parallel to the transistor with the negative terminal of the LED connected to the emitter and the positive terminal connected to the collector. This is my LED. The longer terminal is positive, the short one is negative. So the negative terminal is connected to the emitter. So this is my emitter. We connect the negative terminal, and then the positive terminal is connected in the same lane with the collector. And now from our circuit, we have the base terminal is connected to the switch through a resistor. So this is our base terminal. So I'm going to connect a resistor on the base terminal. One leg of a resistor is connected to the base terminal, and then the other leg is connected to the switch. So this is my switch. To make it easy to be connected to the breadboard, I'm going to attach jumper wires. So from our circuit, we see that from the resistor, the second leg of the resistor is connected to the switch. Now the second terminal of the switch is connected to the positive terminal of the batteries. So the positive terminal. Now we have a second resistor. One terminal of this resistor is connected to the point where the collector meets the positive terminal of the LED. This is my collector terminal, and this is the positive terminal of the LED. So where they meet, I'm going to fix one terminal of the resistor. the second leg of the resistor is connected to the positive terminal. So I'm going to connect it to a positive lane of my breadboard. We're now going to get a jumper wire that connects from the point where the emitter meets the negative terminal of the LED to the negative terminal of the batteries. This is my emitter terminal, and this is the negative terminal of the LED. So where they meet, I'm going to get a jumper wire from the point where they meet to the negative lane of my breadboard. I'm now going to connect the positive terminal of the batteries, the positive lane of the breadboard, which is the red line you are seeing here. And the negative terminal of the batteries, the negative lane of the breadboard, which is the blue line you are seeing here. Now let's test our circuit. So this is our switch. We expect that when our switch is on, the LED is off. So when we turn off the switch, as we can see, our LED is on. When the switch is open, that is when the switch is off, no current is applied to the base of the transistor. And so no base current flows into the transistor. The transistor remains in the off state, acting like an open switch between the collector and the emitter. Since the transistor is off, current flows from the power supply through the resistor and directly through the LED to the emitter. And therefore, the LED receives the necessary current to light up. And so, the LED is on when the switch is open. When the switch is closed, a positive voltage is applied to the base of the transistor, causing a small base current to flow. The transistor then turns on, allowing current to flow from the collector to the emitter. The transistor acts like a closed switch, creating a low resistance path between the collector and the emitter. Since the transistor is on and it provides a low resistance path, most of the current flows through the transistor instead of the LED. As a result, the LED is deprived of current and therefore it turns off. Let's now construct the truth table for our NOT gate. In our table, we have the input and the output. This can either be a 0 or a 1. When we input a 0, so that means we press the 0 part of our switch. We see that our LED is on, so that means that our output is 1. When we input a 1, so we turn our switch on, we see that the LED is off, so that means that our output is 0. So this forms the truth table of our NOT gate. Thank you for joining us today. In this video, we have built our second logic circuit, that is the NOT gate, using simple components like the transistor, LED, resistors, and others. I hope this helped you to understand how the NOT gate works at the fundamental level. Thank you for joining us today. Don't forget to like and subscribe to our channel. See you in the next one. Bye-bye.